Hello class, this is Gabby. Welcome to your first Natural Disasters lecture. So in this lecture we'll go over Chapter 1, which is Introduction to Natural Hazards. This first slide that you're seeing, as well as the following slide, which I'll show you in a second, are both images of the Oso landslide, which is a landslide that happened, and I guess, depending on how you look at it, continues to occur in Washington State. So you see here the kind of side view of it. So you're seeing the hill slope and you're seeing the massive landslide and all the debris falling into the river over here. In this picture right here, you see a similar, but yet frontal view of where it is. As you're seeing, it's here in Washington State, in the, the Mount Baker Snoqualmie National Forest. So this particular massive landslide that you're seeing in the image happened in the spring of 2014. And during this time, this area of Washington State had just been getting a lot of water. Also, right before that, they had gotten a particularly wet winter. And because of the snow melt from the snow of that winter, as well as the continued rainfall precipitation that happened in the spring, it was easier for the slope to be completely saturated, meaning be completely full of water, which meant that holding that maximum amount of water that it could possibly hold was overpassed. It was gone over the limit. And so with just a little bit more precipitation, which happened that day, the added water weight caused the slope to simply give or to fail. So here really gravity did its job and brought part of the hill slope downhill, which is again what we saw in the two pictures. So all of that material that got carried downhill fell on the river below, which is that you're seeing right here. And you see that the river is flowing left to right from the image. So as the water of the river continued to flow upstream from the landslide, most of that water was actually dammed by the landslide deposits. So if you imagine the deposits being here, this would create kind of like a natural dam, and the water that was flowing from the left here got dammed. And so that started making a bit of a natural reservoir, if you would. And flooding in the area just before the landslide started to occur. So all this area started to get flooded. Then, once the amount of water that was great enough to overcome the new barrier, much of this water came rushing downstream after having picked up much of that sediment that was now in the riverbed. So, again, deposits over here, the water eventually got so high and so much water behind it that it overcame that barrier and it flowed downstream at a fast speed, carrying much of the sediment that had been deposited and made the barrier before. So the combination of factors made for a very dangerous flood. If you think about it, this flood was filled with this surplus sediment, and it caused major problems for the community that was downstream, so a little bit of ways away from here. In that community, many homes were destroyed, and the flooding / mud flow from the river took about 30 lives from that community. So this example that I just gave you is a wonderful example for what a typical natural disaster is. So a natural disaster is an event where several people were hurt or lost their lives due to a natural process. I'll give you the specifics of what the definition is for natural disaster versus natural hazard versus natural catastrophe, so on and so forth, as we go throughout the chapter, okay? So we know that these natural processes, that is what happens before it becomes a hazard really, will continue to occur, and we know this by geologic records. So we know that this has happened in the past from the geologic records, and by our experience so far historically, we know that they will continue to occur, as they have since pretty much Earth's formation, right? So, granted, they might change, they might become greater or lesser, their degree, and depending on the conditions, we might see more or less of them, or maybe the magnitude of them will change. But overall, the motivation to teach and for you to take this class is to really tie the human interaction and the effects with these natural processes to see how both of those play out, how both of those can live in the same earth. Alright, so the objectives of this course overall, and particularly of this chapter, is to separate an Earth's process from something that occurs on the Earth every day, and to separate those from what then will become a natural hazard. So an understanding of what a hazard is first, then introducing when this hazard could become a disaster, and if severe enough, this could become a catastrophe. So throughout the chapter, you will realize that natural hazards are caused by generally high energy Earth's processes, but these Earth's processes don't become hazards, disasters, or catastrophes until there has been some interaction with humans. That's very key. So they're just Earth's processes, but if we get involved somehow, then they could become hazards, disasters, or catastrophes. So by the end of the chapter, you'll be able to define the difference between those four words that have been outlined in the figure of the slide right here, okay? So in this chapter, you will also become familiar with some of the geologic cycles. So we'll go over those later in the chapter. But ultimately, it is the geologic cycles, so you can start thinking about what these could be, that drive the Earth's processes, which may eventually, again, those processes turn into hazards, disasters, or catastrophes. So this relationship that we have between the cycles and their effect on the Earth's processes is based on the understanding of the scientific method, which we'll also touch on briefly. And we'll cover it in more detail again later in the chapter and as we go through other chapters as well. So I'm going to skip through the scientific method for right now, but if you want to look at this image, please feel free to pause the video and look at it more thoroughly. By the end of the chapter, you'll also be, or hopefully you'll be able to understand what a risk assessment is and what components it has and what those components can tell you. You also understand the relationship between the magnitude and the frequency of a hazard event, or a hazardous event, I should say. So the magnitude of an event is how large a hazard can be, or rather what is the size of it, compared to how frequently that size of an event occurs. Again, we'll look at them in a little bit more detail later, but just so that you know what you are hearing. Additionally, you'll also be able to recognize links between natural hazards and their physical environment. So there's a bit of terminology in there, but basically what this is getting at is that depending where you are on the Earth's surface, you will be more or less likely to be affected by a specific type or types of natural hazards. And lastly, you'll also hopefully have an understanding of how changes in the human population and changes in our land use will directly alter the effects of natural hazards, which may, again, depending on that alteration, become disasters or catastrophes. Alright, so when you registered for this course, you may recall that this is a geology class. So why do you think that we need geology to understand natural hazards? For example, why do we need geology to understand that the flood that you see in the right image right here causes a natural hazard that is capable of displacing a large number of people for what could be a potentially large amount of time, which is again what you're seeing on the left image right here. You're seeing that many people get displaced from a flood like this. And why is geology important in that scenario? So one of the ways in which this can be easily explained is through the phrase that is in quotes here at the bottom of the slide. So that quote says, "The present is the key to the past." And this is an idea that was coined early in geology in the early 1800s or late 1700s, I'm not exactly sure. by James Hutton. So James Hutton is one of the fathers of geology, if you would. And that phrase ultimately drives our understanding of natural hazards. So I'll let you ponder that a little bit, and as we go further in the chapter, you'll understand how it is that matters. So what really is a natural hazard? It is a potential danger that poses a threat to people or property that is caused by nature. So again, a natural hazard is a potential danger that poses a threat to people or property that is caused by nature. So there you realize that it is a natural process, right? But once it causes that potential threat to people or their property, then it becomes a hazard. So all of these processes, such as a wildfire, like you're seeing here, right? Or a flooding event, like you're seeing here, or an earthquake, which I don't have a picture of right here, but I think you know what it causes, are part of the Earth's processes. But again, it's not until we get involved or after properties of ours or buildings of ours or any sort of land that we use for our benefit actually interacts with that natural process, or rather intersects with that process, that is when it becomes a hazard. All right, so a few years back, this article by Popular Science had a relatively funny title that I think is worth looking into. So the title of the article is, "Where in the US is nature most likely to kill you?" And this begs a pretty similar question of the location for natural hazards, in truth. So where are they most likely to occur in the US, and to what intensity, to what degree, that magnitude, are they going to present themselves so that you could potentially die from them? So if we dive a little bit deeper into this first question from the article, there are two main questions that I'd like you to think about. The first one is, which states do you think have the highest property damage from a natural hazard or disaster? And then the second one would be, which states do you think suffer the greatest loss of life from natural disasters? Those two questions are related, but they're still pretty different. So they get at two different ways in which we actually quantify the effects of natural hazards. By examining the property damage and the loss of life. So for the first question, you may be thinking about places that perhaps possess expensive housing and buildings, and where natural hazards occur at the same time. So perhaps states that have a greater economic prosperity that get continual damage from natural hazards. And then for the second question, which is again quantifying the effects of natural hazards on human life itself, you can be thinking of states with a larger number of people that would be greatly affected, and perhaps not necessarily that have to be economically sound or as economically prosperous. But again, you do want natural hazards to happen in those states where you have a large number of people, and then combining those two effects, you could probably think of either or the answer for the second one. So in the next slide, I'm going to show you the answers. So pause the video for a second, think about which 3 states or 2 states you think could fall under either question. So if we look at the answers to the first questions, it is states like Florida, California, and Louisiana that suffer the greatest property damage. So these states are more affluent, meaning people turn to earn a little bit more money, or overall the state is in better condition than other states. And it is a combination of events like flooding, like hurricanes, and wildfires mostly, that are mostly responsible for the property damage which occurs as a response to natural disasters in those 3 states. So clearly, wildfires are more influential in California, whether hurricanes are more influential in Florida and Louisiana, but I think that flooding pertains to both of, or all 3 of those states, depending on where you're looking at and depending on times of the year.